Space Shuttle, the era of reusable spacecraft. The arrival of the Space Shuttle heralded a defining chapter in the history of space exploration, one defined by the ambitious idea of reusable space travel. Once the purview of science fiction, the concept of a spaceship that could fly to the stars and come back alive and well was made a reality with the development of the Space Shuttle. The shuttle's unique profile became a symbol of human inventiveness, representing an unwavering commitment to conquering the unknown and turning the sky into a regular destination rather than a rare sight. The winged orbiter, the roaring solid rocket boosters, and the large external fuel tank that launched the Space Shuttle into orbit must all be understood in order to fully grasp the Space Shuttle. It was an intricate and beautiful ensemble, a symphony of strength and accuracy that transported people and goods into the afterlife.
Houston, flight is go. SRO is go. You have a range clear to launch. And CDR. CDR is go.
For 3 decades, the shuttle was a constant in the sky, a reliable intermediary between Earth and space that made it possible to place satellites in orbit, maintain observatories in geosynchronous orbit, and build the International Space Station. This video is a journey through space shuttle history, including its triumphs, tragedies, and enduring legacy in the sake of space exploration. This is the prologue to the epic adventure of a legendary vehicle that changed the course of human history by broadening our vistas, testing our limits, and redefining what it means to go beyond Earth. As we begin this tale, we give thanks for the Space Shuttle's illustrious history and look forward with excitement to the next step in human exploration of space. The dream of a reusable spacecraft. To forge a road to the heavens that was both affordable and sustainable, the inspiration behind the Space Shuttle program was to build reusable spacecraft. This fantasy was born of the golden age of space exploration, a period distinguished by the one-way trips of rockets that left their vestiges in the ocean or spread over the universe. The goal was very clear: design and build a space shuttle that could transport humans and supplies to orbiting research facilities and back to Earth. It was a concept that claimed to make spaceflight more like air travel, with the regularity and dependability of aviation trips. The shuttle would be used for everything from satellite launches and repairs to scientific research and the construction of space stations. In essence, it was meant to connect the heavenly with the mundane, serving as a reusable connection that would help bring the vastness of space closer to the people of Earth. There were several obstacles on the road from concept to completion. The Space Transportation System, STS, more commonly known as the Space Shuttle, was the result of years of technical successes and failures, of technological innovation battling against the restrictions of physics and the bottom line. Engineers and scientists were challenged with creating a one-of-a-kind orbiter that could be launched, navigate space, and survive a fiery re-entry into Earth's atmosphere, all while being able to be repaired and flown again. Safety, performance, and efficiency were all taken into account during the lengthy and intricate design process. The shuttle had to be flexible enough that it could accommodate a wide variety of missions and cargo. There was discussion, redesign, testing, and retesting. Extensive testing was done on the orbiter's thermal protection system, which consisted of groundbreaking heat-resistant tiles and blankets. Since they were the first of their type to be employed in a human spaceflight, the solid rocket boosters presented their own unique set of difficulties.
Altitude 7 miles, 5 miles east of the Kennedy Space Center.
Go and throttle up. Roger, go and throttle up.
The finished Space Shuttle design, a complicated machine with many interconnected parts, was the result of this intensive era of development. Although the orbiter is what most people picture when they hear shuttle, it was just one component of the whole system. The orbiter's 2 solid rocket boosters were attached to it to provide the thrust required to lift off from the planet's surface. After each flight, they were meant to be parachuted into the ocean and reconditioned for future use. The external fuel tank supplied the shuttle's 3 main engines with liquid hydrogen and liquid oxygen they required to function. The fuel tank was non-reusable, unlike the rockets and the orbiter, and would separate and burn up on re-entry to the Earth's atmosphere. The orbiter itself was an engineering wonder, with room for the whole crew, the cargo, and all essential equipment for interplanetary flight. It had a cargo hold that could release satellites into orbit, or bring them in for servicing. The remote manipulator system, the shuttle's robotic arm, became a symbol of the program's success because of its ability to let astronauts move heavy objects around in space. The shuttle's high-tech docking and communication technologies made it possible for its crew to perform multidisciplinary scientific exploration on the International Space Station. The Space Shuttle became a symbol of humanity's yearning to explore the cosmos and discover what lies beyond our solar system. The idea behind it ushered in a new era of space policy and ambition, and paved the way for some of the most memorable events in space travel. The first launch of the Space Shuttle was preceded by rigorous and historic preparations. A symphony of engineers, technicians, astronauts, and countless more professionals worked relentlessly while the world watched to make sure the shuttle was ready for its historic mission. Columbia, the shuttle, was scheduled to launch on STS-1, a test flight that would either validate the years of labor and investment or send the crew back to the drawing board. There was a long list of things to do before taking off. The orbiter underwent a battery of tests and simulations. The solid rock boosters were examined and mounted, and the large external fuel tank was loaded with its flammable payload. Before becoming the first humans to operate NASA's reusable orbiter, John Young and Robert Crippen had extensive training that included exhaustive simulations of the whole mission from liftoff to orbit to the crucial re-entry and landing. Never before has a crewed spacecraft been put through such a rigorous test, and the stakes could not have been greater. There was no space in the shuttle's design for an emergency exit while in flight. Thus, the shuttle's dependability had to be built from the ground up. The Space Shuttle Columbia's engines fired up for the first time on April the 12th, 1981, propelling the ship away from the gravitational pull of Earth. Because it was the first time a manned winged spacecraft had been sent into orbit and subsequently returned to land on a runway, STS-1 was a watershed moment in the history of space travel. All three parts of the shuttle system, orbiter, solid rocket boosters, and external tank, had to work together. Thus, validating their performance in flight was a simple but lofty goal. Columbia's fiery trail traced a dramatic path across the sky as the spaceship climbed into orbit. Encased in the orbiter, Young and Crippen watched over the shuttle's systems as it climbed into orbit. Testing the shuttle's systems and collecting data vital to the program's future would take up the next 54 hours while they orbited the Earth. The world watched as Columbia finished its orbits, a show of endurance and capacity that would set the tone for future missions.
Roger, Columbia on a roll.
Columbia's successful flight was a landmark event for NASA and the globe. The joy at its successful landing on Earth was shared by people all throughout the world.
Columbia, Houston,
The success of the shuttle mission demonstrated that a spacecraft could be sent into orbit and recovered for future use. This feat paved the way for the shuttle to become an integral part of space exploration for the next 3 decades. A dependable vehicle that would launch people's satellites and scientific experiments.
Okay, looks like we got a good SOP ship.
The effects of the first shuttle flight extended much beyond the mission's instant success. It marked the beginning of a new age in which space travel would become more accessible, and it altered the way humans think about and plan for such endeavors. All spacecraft, from those now in development to those still in the conceptual stage, owe a debt of gratitude to the shuttle for its groundbreaking design and capabilities. The first mission of Columbia was a cultural phenomenon that influenced a whole new generation of innovators and visionaries. It proved that the boundary between Earth and the stars did not have to be a remote, icy area.
Roger, go ahead. And it's solid as a rock, man. Okay, Houston, we got a good Miko. Miko. Roger, we got Miko. And we got a Miko confirmed. And confirmed. Let's get off the tank now. Got him IMU bites, flight. No problem. Ignore him. Okay. Ignore the IMU bites, Capcom.
Columbia, Houston, you can ignore the IMU bites.
Roger, Houston, and we've had ET7. Roger on the SEP. Okay, let's get an nice status here.
It proved that the boundary between Earth and the stars did not have to be a remote, icy area that could only be reached once by one-time use rockets and capsules. With the launch of the Space Shuttle, human spaceflight changed forever. The Space Shuttle program has been dynamic and ever-changing from its initial launch in 1981. It has mirrored the changing goals and objectives of space exploration. The shuttle fleet had multiple updates during its 30-year lifetime, each of which was intended to boost efficiency, security, and adaptability. It was obvious after the first flights that improvements were required to achieve NASA's lofty aims. To make sure the orbiter could survive re-entry temperatures, NASA constantly improved the shuttle's thermal protection system. Iterative modifications were made to main engines, the beating heart of the shuttle, to increase their power and dependability. Avionics systems aboard the shuttle were updated, and the most cutting-edge computer technology to improve efficiency and safety. These systems include navigation and flight control. The shuttle's payload capacity was increased throughout time, enabling for the launch of heavier and more complicated payloads. Improvements to the orbiter's maneuvering system and the inclusion of the extended duration orbiter payload allowed for longer shuttle missions and expanded orbital capabilities. These enhancements were implemented throughout the whole fleet of orbiters, giving the entire program access to the most cutting-edge technology available. This idea of never stopping to rest on one's laurels was key to the thinking behind the shuttle program, which was always pushing the envelope of what was thought to be feasible. Columbia, Challenger, Discovery, Atlantis, and Endeavour were the 5 operational orbiters of the shuttle fleet. As the fleet's first ship, Columbia was seen as the trailblazer, blazing the path for future endeavours. The tragic loss of the Challenger in 1986 highlighted the need of a steadfast dedication to safety in space research. After the horrific catastrophes that befell the shuttle program twice, Discovery became the program's mainstay, flying more flights than any other orbiter and returning to duty after each incident.
Space Shuttle Discovery,
The 2011 last shuttle flight was only one of several remarkable accomplishments that Atlantis could brag about. The Endeavour, the newest ship in the fleet, was pieced together from leftover materials in a spirit of perseverance and rebirth. The missions each orbiter performed and the people who served on board gave each spacecraft a unique personality and legacy. They carried the tales of human success, the echoes of failures and recoveries, and the shared experiences of hundreds of astronauts. These accounts are more than simply a part of space history. They are inspiring examples of human determination, bravery, and creativity.
Following 2 return-to-flight missions by Space Shuttle Discovery designed to test safety procedures, Atlantis stood ready to support STS-115 in 2006.
With each flight adding to the heritage of scientific and exploratory accomplishment, the shuttle program has a lengthy and historic record of missions and achievements. Among them were the Shuttle Mir missions, which paved the way for international collaboration with Russia, the launch and maintenance of several more satellites, and the deployment of the Hubble Space Telescope. As a demonstration of its capabilities and the worldwide cooperation it enabled, the shuttle was crucial to the building and resupply of the Worldwide Space Station, ISS. The Space Shuttle also played an important role in scientific exploration. The shuttle's cargo hold was converted into a laboratory for hundreds of experiments during the Space Lab missions, covering fields as diverse as astronomy, zoology, physics, and human biology. As a result of these flights, scientists now have a better idea of how microgravity affects different types of life and materials. The accomplishments of the shuttle fleet are not limited to these missions. As a whole, the initiative increased not just our technological, but also our mental grasp of what is possible in space.
Agency's Columbus Laboratory. Astronauts Rex Walheim, Stan Love, and Hans Schlegel also replaced several components of station hardware over the course of 3 spacewalks.
The shuttle transformed outer space into a workplace classroom and a construction site, giving rise to the idea of space as a last frontier for mankind.
It became the first flight in 9 years for Atlantis to a destination other than the International Space Station.
Bypass across the board, Scooter, no action.
To the Hubble Space Telescope. During the 13-day flight, the crew outfitted Hubble with 2 new imaging devices, the Cosmic Origins Spectrograph and the Wide Field Planetary Camera 3. Over 5 complex spacewalks, the crew replaced and upgraded many key components on the venerable telescope, giving Hubble a new lease on life and extending its vision to beyond the limits of our solar system, with a clarity once thought to be inconceivable. Atlantis has traveled more than 115 million miles in the pursuit of exploration. Its legacy enabled NASA and its international partners to accomplish some of the most complex work in human spaceflight history. Work that has yielded immeasurable benefits.
The Space Shuttle was not only a means of interplanetary transportation, but also a flexible laboratory. Life science, physics, astronomy, and materials science investigations benefited greatly from the one-of-a-kind conditions available in space. Each scientific shuttle voyage was a veritable laboratory, full with research that couldn't be done due to Earth's oppressive gravity. The orbiter's middeck and cargo bay were modified to house Space Lab, a portable lab where astronauts performed many tests. The microgravity of space allows researchers to explore phenomena free from gravity-induced artifacts, yielding new insights into fluid dynamics, combustion, biotechnology, and medicine. Long-duration spaceflight and its effects on the human body were studied thanks to the shuttle, leading to advances in medication creation, medical technology, and the knowledge of the human body in space. The shuttle's capacity for scientific exploration was bolstered by the installation of the Space Lab module, known as the International Microgravity Laboratory. To study the basic behaviors of materials, biological creatures, and physical systems in a near weightless condition, scientists from all around the globe fought for a position in this orbital lab. The study of complicated fluids, cell biology, and protein crystal formation are just a few of the areas that benefited greatly from these missions. Deploying satellites and telescopes was one of the Space Shuttle's key functions, and it had far-reaching effects on our ability to communicate, predict the weather, find our way around, and learn about the cosmos. The remote manipulator system, the shuttle's robotic arm, carefully released these packages into space after transporting them to orbit in the cargo hold.
Harold Bobko, the classified Department of Defense flight, was the first of 5 Pentagon missions Atlantis completed. After traveling more than 1 million miles, Atlantis landed at Edwards Air Force Base just 4 days later, on October 7th.
Commercial and military satellite activities benefited greatly from these capabilities, and scientific exploration was also given a significant boost. The shuttle fleet altered the way in which spacecraft connected with Earth by deploying a number of important satellites, including the trafficking and data relay satellites. These satellites made it possible for spacecraft in low Earth orbit, such as the Space Shuttle, to remain in constant contact with ground control. Due in large part to the Landsat satellites' contributions to environmental monitoring and natural resource management, several fields have benefited greatly from their deployment. One of the most notable satellite launches was the Galileo probe, which was deployed on a mission to investigate Jupiter and its satellites. In 1989, the shuttle Atlantis successfully launched Galileo, marking a major milestone in humankind's efforts to explore the solar system. In terms of scientific accomplishments, the shuttle program's servicing flights for the Hubble Space Telescope, HST, stand out as the apex. When Hubble was first launched in 1990, its main mirror was defective, causing it to have blurry images. STS-61, the first shuttle maintenance mission, was one of the most difficult and keenly anticipated missions of all time, taking place in 1993. Hubble's vision was restored after a series of spacewalks during which astronauts installed new sensors and corrective optics. Advanced cameras and spectrographs were added to the Hubble during subsequent servicing flights, expanding the telescope's capabilities. The telescope's life was prolonged thanks to these expeditions, so it could keep beaming back stunning pictures and crucial data that have revolutionized our knowledge of the universe. The science of these servicing missions underlined the shuttle's position as a maintenance vehicle, able to repair and upgrade satellites and telescopes
and
in
lift
orbit.
off of the Space Shuttle Atlantis on a mission that will herald a new day of international cooperation.
The shuttle's capacity to return to Earth also made it possible to bring satellites back to Earth for servicing or maintenance. The Space Shuttle has carried satellites like the Long Duration Exposure Facility and the Solar Maximum Mission Satellite, down to Earth for servicing or scientific study before sending them back into orbit or retiring them. The shuttle's program's capacity to retrieve objects was a first in spaceflight and a tribute to human ingenuity and adaptability. The Space Shuttle was more than just a means of getting people and supplies from point A to point B. It was also a vehicle of discovery that greatly increased humanity's time and ability to work in space. The shuttle program's scientific experiments and satellite launches forever altered the course of history, leaving behind a legacy that continues to shape our exploration of the cosmos.
Just about time for the Spirit of 76 to wake up the Space Shuttle, so have a great flight. All right, we'll put that in work. Thank you very much.
2, 1. Booster ignition and liftoff of Atlantis.
The role of the shuttle in building the International Space Station. Assembly of the International Space Station was undoubtedly the most enormous building project ever undertaken, and the Space Shuttle program played a crucial part in this. The International Space Station is a shining example of what can be accomplished when countries work together toward a shared objective. Shuttle flights were vital to carrying modules, supplies, and staff, thereby acting as the backbone of the station's construction period. The many modules that would eventually make up the ISS were carried from Earth to orbit in the shuttle's payload bay on a number of separate trips. Together, spacewalking astronauts and the shuttle's robotic arm danced in the vacuum of space to connect and integrate these components, creating a complicated structure. From the pioneering Zara module to the European Columbus Laboratory and the Japanese Kibo Laboratory, each mission provided crucial information. The spirit of international collaboration was also conveyed on these shuttle flights. In addition to the actual components, NASA, Roscosmos, ESA, JAXA, and CSA all had a hand in building the International Space Station, making it a true example of teamwork in the service of humanity. The shuttle's ability to rotate foreign crews created a one-of-a-kind setting in which astronauts from many nations could work and live together, learning from and teaching one another about their cultures while in orbit. The shuttle's capacity to transport big crews and equipment sparked collaborations with several other space organizations. As part of these partnerships, foreign astronauts often flew with NASA crews on missions to perform experiments, install satellites, and test new technology. One of the first examples of post-Cold War space cooperation was the Shuttle Mir program with Russia, which started in the 1990s. Partnership on the ISS was made possible in part because of the shuttle visits to the Russia space station Mir. These partnerships encouraged more than just the exchange of material goods. They also promoted the dissemination of information and the development of new skill sets. International partners' space projects benefited greatly from the expertise gained by shuttle astronauts working in orbit. International astronauts were able to train at NASA centers thanks to the shuttle, cementing a culture of collaboration and interchange.
And what are you doing today?
Well, today Mike and I are going to move the PMM, which is the big module that's currently in Payload Bay of Discovery, over to the station, and that will complete the assembly of the ISS.
As time went on, the Space Shuttle developed into an instrument for world unification rather than merely a symbol of American space aspiration. Its missions proved that space travel may be a diplomatic means of advancing global knowledge and understanding among countries. Launching from American territory with multinational components and a varied crew, the shuttle operations epitomized the spirit of international cooperation. Transporting supplies and crew from all over the world, the Space Shuttle was crucial in fostering a common space program across nations. In space, differences between nations faded into the background, and people's shared humanity and the dangers and benefits of spaceflight became more prominent. The worldwide crews of the Space Shuttle missions developed a sense of earthlinghood as they gazed down on a borderless Earth against a great background of space. This paradigm change was a significant byproduct of the combined efforts of the worldwide teams. In addition to its primary scientific and transportation roles, the shuttle was also an important diplomatic avenue. It communicated the idea that in space, collaboration is not merely desirable, but crucial. The intricacy of space missions necessitated the collaboration of experts from across the globe. The shuttle was a meeting place for people from all around the world, and the results were better than anything any one nation could have accomplished on its own. In addition, the worldwide impact of the shuttle's flights was felt well below the Earth's surface. They motivated a new generation of scientists and engineers all around the globe to pursue careers in STEM, science, technology, engineering, and mathematics fields. They inspired discussion on humanity's shared destiny and our planet's precarious state in the universe. The shuttle wove a pattern of interconnection in the broad fabric of space exploration, highlighting the concept that international cooperation in space may serve as a model for international cooperation on Earth. The shuttle's legacy of international collaboration provides both a foundation and a light for the world's space agencies as they plan for future initiatives like lunar outposts and Mars exploration. Despite its many successes, the Space Shuttle program was marred by tragedy. Both the Challenger disasters in 1986 and the Columbia tragedy in 2003 are tragic episodes in the annals of space travel, highlighting the points at which hopeful ascension gave way to heartbreaking tragedy. Krista McAuliffe, who would have been the first teacher in space, was one of 7 astronauts killed when the Challenger shuttle exploded only 73 seconds into the mission. In 2003, 7 astronauts perished when the Space Shuttle Columbia destroyed after re-entry owing to defective thermal protection systems. These catastrophes were national and worldwide tragedies that brought the Space Shuttle program to a stop. They caused a flood of tears and contemplation across NASA and the space community at large. Accidents occurred, and the investigations revealed the technological and organizational flaws that caused them. Challenger's, Rogers Commission, and Columbia's Accident Investigation Board both found problems with NASA's culture and communication, as well as mechanical breakdowns and the hazards associated with spaceflight.
Those are the parents, Ed and Grace Corrigan, the parents of Krista McAuliffe. It appears at this point they don't know what has happened, but others, of course, realize that something seriously has gone wrong. In slow motion now. To my eye, at least, it appears that the entire external tank just came apart and became one gigantic fireball. It would have been, at that point, a bomb. To the right, you see the solid rocket booster.
Spaceflight is dangerous, as shown by the Challenger and Columbia tragedies. The subsequent investigations resulted in extensive adjustments to NASA's operations and safety regulations. For Challenger, the solid rocket booster design was revised, and for Columbia, a thorough on-orbit inspection process was developed to assure the integrity of the thermal protection system before re-entry. As a result of the tragedies, NASA has revised its approach to risk assessment and decision-making. It became clear that more stringent design and testing standards were required, as well as safety culture that encourage engineers and astronauts to raise concerns. These changes were not superficial upgrades, but rather a commitment to more caution and detail in human spaceflight. The resilience and recovery of the Shuttle program. The Shuttle program showed extraordinary resilience in the face of devastating Challenger and Columbia disasters. Each time the program was put on hold, it was utilized to regroup and prepare for another round of flights with a heightened sense of alertness. The catastrophes united the space community in their desire to remember the deceased by continuing the search for knowledge and exploration.
The array of missions Atlantis has flown is as wide as the oceans once sailed by the 20th century research vessel for which it was named. Atlantis has flown missions for national security, for interplanetary exploration, and to foster international cooperation. On October 3, 1985, Atlantis launched from Pad 39A on its maiden voyage, STS-51J.
The program's turnaround was defined by a return to exploration's bedrock values: boldness, tenacity, and a willingness to confront the unknown while also working to learn from and correct previous errors. The return to flight missions post-Challenger and post-Columbia were emotional and technological achievements, embodying the human spirit's unwillingness to be deterred by hardship. After these mishaps, the shuttle went on to play a crucial role in space exploration once again, by completing a number of missions, including those related to the building of the ISS, scientific research, and satellite deployments. The program was officially shut down in 2011. Although it was more of a celebration of the major achievements it had made to human spaceflight. The shuttle program's legacy is therefore a mixed bag of happiness and loss. The journey to the stars is riddled with danger, but this story serves as a reminder that we can come back from any obstacle and be better for having faced it. The shuttle program's achievements against the background of its tragedies highlight the duality of human exploration, illuminating the dangers we face in pursuit of progress and the relentless tenacity that marks our voyage into the last frontier. On July 21st, 2011, the Space Shuttle Atlantis made its last landing, marking the end of the Space Shuttle program and a new era in human spaceflight. This was a touching occasion, full of mixed emotions. Nostalgia and joy at the program's success, and the sadness of handing the mantle. A number of reasons, including the need for a new space exploration plan, financial constraints, and the need to create a new generation of spacecraft, led to the decision to phase down the shuttle program. While the final shuttle mission ended a spacecraft's trip, it also closed a major chapter in human exploration of space. The Space Shuttle represented American innovation and international collaboration in space for almost 30 years. It was a moment of tremendous learning, pushing the frontiers of what was technically feasible and broadening the horizons of human potential. After the program ended, there was some time for contemplation of the gains obtained and the costs borne. The shuttle's impact on space travel cannot be overstated. It was this spacecraft that carried out many scientific experiments, helped construct the International Space Station, launched and serviced the Hubble Space Telescope, and much, much more. Important satellites that underpin global communication, weather forecasting, and navigation could only be sent into orbit thanks to the shuttle. Our knowledge of how to live and operate in space was also greatly expanded by the program. Medicine, materials, science, and our knowledge of the cosmos have all benefited greatly from the shuttle's microgravity studies.
Mission complete, Houston. After serving the world for over 30 years, the Space Shuttle earned its place in history and come to a final stop.
The legacy of the Space Shuttle may be seen in present and future efforts to build and explore space. Its influence may be seen in the way modern spaceships are built, with an emphasis on safety, dependability, and reusability. Modern commercial crew spacecraft have much to thank the shuttle for. They incorporate lessons learned from its successes and failures in an effort to improve the reliability and safety of human spaceflight. The shuttle's conclusion also sparked a change in space policy, supporting a booming commercial space industry. SpaceX, Blue Origin, and other startups are leading the way in creating new spacecraft that can transport people and supplies to the International Space Station and beyond. All the knowledge and expertise gained during the shuttle program have been incorporated into the design of these new spacecraft. The shuttle program's goals to normalize space travel and make it more accessible continue to this day. The shuttle was crucial in laying the framework for future missions to the Moon and Mars. The multinational partnership generated by the initiative set a pattern for future joint projects in space. In conclusion, the Space Shuttle's legacy is intertwined with the history, present, and future of space travel. It serves as a reminder of what we can accomplish as a species when we focus on our goals and work tirelessly towards them. Even if the shuttle program has ended, the voyage it started lives on, encouraging new generations to imagine a world where we are limited not by our physical surroundings, but by the scope of our aspirations and the strength of our will. The adventures of the Space Shuttle in space have been filled with determination, bravery, and new knowledge. Its legacy is a tapestry of scientific discovery, technical invention, and the triumph of human will. As the Space Shuttle program comes to an end, we may look back with pride on our accomplishments in expanding our understanding of the cosmos and bringing the stars within reach. With its 30-year legacy of regularly transporting people into orbit, constructing the International Space Station, repairing satellites, and facilitating groundbreaking research, this Space Shuttle has come to represent the era of space travel. Its impact on space exploration is far-reaching, from helping launch key observatories like the Hubble Space Telescope to establishing cooperative relationship among nations. The shuttle left an unmistakable mark on space exploration and technology, and its story is full of triumph and setbacks. The lasting impact of the shuttle program lay not merely in the technology left behind or the scientific data acquired, but in the human experiences it enabled and the aspirations it inspired. The Space Shuttle was an inspiration to many people over the years. It showed them that the stars were not the limit. The conclusion of the program marks a significant turning point in history, providing an opportunity to reflect on and pay respect to the achievements of the many people, including engineers, scientists, astronauts, and support personnel who worked tirelessly to further humanity's quest for knowledge and adventure.